Hello everyone. So this is our logic gate module which is part of our Playtronics kit. So logic gates are the basic building block of any modern computational device, whether your laptop, computer, calculator, any microcontroller basically will have logic gates. So the first gate selected here is AND gate, and this is the mode button. And for signal, like I have connected two buttons, button A and B. So this is A, this is B, and this is the output LED. So what AND gate does? AND gate basically, when both the signals are true, then only the output will be true. Otherwise the output will be false. So like when both the signals are false, or like if only one signal is true, then the output will be false. Otherwise, when both the signals are true, the output will be true. So currently, like both the signals are false, so output is false. If I press 1, still the output is false only. The LED is off only. But when I press both, the LED will glow. So like when both the signals are high, then only the LED will turn on. Second gate is OR gate. So for OR gate, if any signal is true, then the output will become true. And when the both signals are false, then the output will remain false. But if any signal becomes true, or like both signals become true, then the output will become true. So let's just see the demo. So if I press this signal A, then the LED will turn on. If I press signal B, the LED will turn on. If I press both, then also the LED will turn on. But if both are 0, the LED is turned off. So the third is NOT gate. So NOT gate requires only one signal. So what it does is, it reverses the signal coming on A, input A. So if it's 0 here, it will become 1. If it is 1, it will become 0. So currently it's 0, it is becoming 1. So if I make it 1, it will become 0. Then you have XOR. So what XOR does it? When the both signals are different, then the output will become 1. If the both signals are same, like 0 0 or 1 1, then the output will become 0. So currently both signals are same 0 0, so output is 0. When the both, if any signal becomes 1, the output will become 1. If both again will become 1, the output will become again 0. So both signals need to be different. Then you have NAND gate. NAND gate is basically opposite of AND, like NOT plus AND becomes your NAND. So here it is 0 0 0, here it is 1 1 1, here it is 1, here it becomes 0. So when both signals are true, then it will become false. If any signal is false, then the output will become true. So like both are false, output is true. One is true, one is false, the output is still true. But if I press both, so both signals are true, output has become false. Then you have NOR gate. So NOR gate is OR plus NOT. So here it is 0 1 1 1, here it is 1 0 0 0. So same here, like when both signals are 0, then it will become 1. If any signal is 1, then it will become 0. So like both are 0, then it is becoming 1. If any signal becomes 1, output will become 0. So both are 1, output is still 0. If any signal is 1, output is 0. Then you have XNOR. XNOR is XOR plus NOT. So here you have 0 1 1 0. Here you have 1 0 0 1. So what it does, it's like both signals are same, then only it will become 1. So currently both signals are 0, it is 1. If any signal is different from the other signal like 1 0 or 0 1, output is 0. If both signals are same 0 0 or both signals are same like 1 1, then the output is 1. Then the last is toggle. Toggle is basically your buffer output, but it is kind of latch. So like when the signal A is rising, it triggers the change in the previous state. So like the previous state is off. So when I press this, it will toggle this. When I press again, it will again toggle this. So it's kind of your on off switch in appliances, like where you just have a one push button to turn it off and turn it on. So these modules are like very interesting for kids to learn some of the very advanced concept in electronics engineering. These are the basic building blocks, foundational unit of your modern computational devices. So when kids do hands-on learning, they'll not only learn faster, but they enjoy playing with these kind of module, and they develop keen interest into your computer science or like electronics. So I hope you like this video. Thanks.